Hello and welcome to the lecture 8 of the Learning About Learning lecture series. And so far what we have seen is the development of the Rescorla Wagner model as a good predictor of associative strength, or to say the good predictor of behavioral response that one can expect from an animal trained in a behavior, right, as a function of number of exposures that you subject the animal for a CSUS presentation. So, in essence the model talks about existence of a maximal response, we call it as Vmax, which is a function of US alone, and there exists a associativity coefficient, or we call it as alpha in our description. It describes the rate at which the learning can happen, right, that the fraction of the maximal response that can be associated, that can be expected from the animal to exhibit in its as a change in behavioral response in its repeated exposures. Now using those principles we are investigating, or we were actually looking at how one can explain the observations that are seemingly non-intuitive at the first place, starting from Gaussian-Colling's experiment of associating to different extent a given CS to different US. When you have a simultaneous presentation of multiple CSS with multiple US, there are certain CS prefer to associate with a particular US better than the other. In the specific case we saw that flavor tend to be associated with the malaise, stomach malaise that can be induced as an US than a tone or a light. On the other hand, a tone or a light is much more easier for the animal to associate with a shock, electric shock, compared to a flavor, right. So, then we also talked about a Cummins blocking experiment wherein CS that is pre-learned, if you have pre-learned a CS and then the animal has associated with the occurrence of a US, then when you present such a CS along with some other new CS like compound stimuli, right, CS1 plus CS2, like tone you train the animal in before, and then you present the tone along with the light in a compound stimuli to signal occurrence of a shock, then we see that learning the tone before completely inhibits or completely prevents the light to form any association with the shock. We call that as Cummins blocking experiment. We went through the Rescorla Wagner model description and showed how both these effects can be explained using this model, right. Then a little prelude to what we are going to see today is in this lecture is that I talked about how do we go about explaining the contingent presentation being important in acquiring this association for this animal. So, we went back to the example of two groups. In a group in which you have the CS and the US being present in a contingent manner, on the compared to another group where the CS and the US are presented in a completely random manner. There is no apparent relationship between them at all. And we saw that the animal not only learns better in the control group where there is a equal presentation of CS and US, but in the random group they fail to learn, they fail to make any association at all. So, how does Rescorla and Wagner's model captures this? So, in order to understand that, I invoked the idea of compound stimuli. All right, let us look at the experimental group again, and the experimental group consists of tone CS, let us call it as CST, being presented let us say 3 times. However, the US electric shock, we can think of being presented not just at these CSS, but you also have these US occurring at some random places. In such a case, I had said that if you want to talk about learning here, then you need to think of this as a compound stimuli where the compound is of tone CS1, and I said some a background CS, right, we wrote it as CSBGD, the background, right. So, even though, so where is it coming from? It is coming from the fact that even though we as an experimenter did not present any CS, any obvious stimuli for the animal to associate with, in these occurrences of the US, there is by default a background present all throughout. In this case, a background in the sense of the animal being taken by the experimenter into the experimental room, the apparatus in which the experiment, the tone and the shock is being presented. Like that, there could be several stimuli which are unavoidable, but they are present for the animal to associate the CS with. So, we call that as the background stimuli, and that background stimuli by itself is not capable of eliciting any response. Clearly, that is why if you do not have the first CS-US presentation, the animal does not have a response. It is just the way that any other CS would be. However, when you are repeatedly presenting these CS and the US, where you, the experimenter, did not provide the animal with any CS, the animal tends to take the background as the CS in these cases. So, the view of the animal here would be there is a constant presentation of CS background, alright, irrespective of whether we have given it voluntarily or presented it intentionally or not. As a result, the learning that is happening at these places would be learning due to CS tone plus CS background, while in these places it is just CS background. Now, I was arguing in the last class that if you consider that, then we can go back and write the learning or the change in the response on a trial by trial basis. Alright, let us go ahead and write it. So, let us call this as the first trial. I am going to count the trial as according to the occurrence of the US. So, this would be my first trial, that would be following this would be my second trial, and so on and so forth. This will be my nth trial. So, whenever there is an experimenter provided CS, the learning will be distributed between the tone, the experimental provided CS plus the background, and whenever the US is quote unquote coming alone without any CS, any obvious CS, the animal tends to associate with the existing CS, the notional CS, which is a background. So, if you distribute the learning, then for the first kind of trials where they are co-presented, CS tone is presented, then in that case you would write the change in response on the learning itself would be alpha. Now, let us talk in terms of the change in response to just tone alone. So, the alpha tone, that is the associatability of the tone with the shock, and we have the V max. This is fixed, this does not change because given your US strength, which is certain milliamperes of current, you are fixing that V max minus summation of all the stimuli, responses elicited by all the stimuli, right. In this case we can explicitly write it as delta V1 for tone would be alpha tone plus V max minus V tone plus V background. Now, as you can see in the first trial there is no response that the animal can the V background by itself or the tone by itself can elicit. So, both of them are 0. So, as a result what you are having is that your response to the tone increases by alpha amount, alpha times the V max, right. So, if we talk in terms of the fraction of the V max that has been increased, then the change in response, behavioral response here to tone will be delta V1 t which is alpha t times V max. All right. So, now in this trial itself a similar amount of change happens for the background too. V1 for the background will be equal to alpha background times V max minus the same summation term that happened as before. So, I am going to just in short write it as 0, which essentially means alpha BGD times V max. So, at the end of the first exposure, if you look at the change in response for the background and change in response for the tone, they both are differing only in their differing by the amount of associatability, that is the alpha value, that the coefficient of association, how much ever they are different, that much they are different. Now, we can make a reasonable guess here of how, an order of magnitude guess so to speak, of how the alpha background and alpha tone would be. Now, let us look at alpha background itself. Now, the alpha background is the associatability of the background, right. So, this is something to do with the visual stimuli that is present there, odor cues that are present there, and so many different things. So, in effect you would think that the alpha background is at the best same magnitude as that of the tone, or maybe just about, if you do a proper habituation and make sure that everything is the animal gets used to. We will come to the aspect of how that contributes for the specific learning, but the point is if you do that, then you can hope to bring the alpha background within an order of magnitude of the alpha tone, but both of them are more or less equal. In such a case you would see that one can plot what happens to the response, all right. If you look at the behavioral response as a function of trials, okay. If you plot the behavioral response of the animal, and I am going to stick to 2 different colors here. So, the blue represents the CS responses elicited by the CS alone, and the dark green would represent the response that is elicited by the background. So, you would see that this would have gone up by that that much, where this is our alpha tone, okay. So, what I am going to do is I am going to make my plotting easy, I am going to look at the response divided by my V max. Okay. So, you can see in this axis then the maximum that the maximum response, the maximum value each of them can take is V max, but that V max is equal to 1 because is V max, the response equal to V max, in this place the response equal to V max, and hence in this axis that would correspond to 1 because I am taking the response by V max as my measure in this axis. So, let me write it down here. This is the line where the response, behavioral response, becomes equal to that of V max, V m a x. Good. So, in such a case we can actually think of the rise in or the change in the behavioral response as a function of trial as a fractional change in their V max values, I mean in their quest towards the V max values, which is 1, right. So, in here I can think of this as 1 alpha has gone up, it has gone up by 1 alpha. So, then alpha tone, and then if we pick up for background, assuming it is slightly less than alpha, maybe to speak, let us say halfway down alpha tone. So, we can think of this being the response levels, this is alpha background of the animal to pure background. However, what is going to happen is that next time when actually look at the experimental paradigm, next time when the shock comes, when there is a US, right, that is right about here, is not it, right about here, second trial, this is the second trial as we have already written. During the second trial, what is happening is that only the background is present and tone is not present. So, then if you follow the same principle and then write down the change, then here what we have is just since the tone has not present. So, we are only thinking in terms of change in response. This is the second trial for the background will be alpha background times V max minus the summation of both the things present, right. So, which will be alpha tone plus alpha VGD. Now, the way we are actually plotting this graph and this measure, we are actually normalizing with respect to V max. So, it does not matter. So, let us pull it out like this, V max into V max. So, what you can see is that the background, the V2 would increase by the differential amount, right, the summation of these two. So, somewhere here and then whatever the remaining there, right. So, let us see here. So, at the second instance, so this is number 1, at the second instance. So, what the animal is going to look at is that for the background I am already responding by this much. So, since there is no tone, this is it is not a compound stimuli. So, it is just a pure, so I need to rewrite this. So, V max minus, since it is a simple stimuli for the second trial. So, we can write this as V max minus whatever is previously present, which is alpha background times V max, right. So, you would see this as alpha background times 1 minus alpha background times V max. So, now clearly alpha being a value from 0 to 1, This quantity is positive, and what you are going to do is that you are going to gain, the change will be greater than 0. Since the change is greater than 0, there will be a new response for the background, which would be whatever the response for the background that was acquired during the first trial when the co-presented with the tone, plus this new change. Thus, you can see at this point the animal is evaluating, okay, I am responding to the background by this much. However, my maximal response could be that big. So, it is going to look at, it is going to accumulate alpha background fraction of this remaining V max minus V max into 1 minus alpha background, or V max minus alpha background, the present what we have written here. So, alpha background times, just for the brevity I will write it as V max times 1 minus alpha b. So, that it is going to increase its response by that much. So, given the fractions here, so you would expect it to go little bit above or maybe equal to the blue line. And then let us go back, and at the third instance what is going to happen is that if again there is no tone, but only the shock is being presented, the background, this green curve is going to go up, but the blue is going to stay wherever it is until a point where the tone and the background is both are presented. At that instance the animal, so let us go few steps more. In the third step, draw the curve once more. In the third instance you can see that it is a continuous, because there is nothing has happened, it is a continuous growth of the association. So, here there will be a slight of a little bit of a kink, because there is a change in the distribution of the learning, while the tone curve will be continuing to remain somewhere like at this point. So, let us talk about, so that is the first trial, that is the end of the second trial, and maybe right about here the third, means trial here defined by the occurrence of the USs, third occurrence of the US. During the fourth occurrence, according to our experimental design, the tone is presented along with the shock. So, the background is also present. At that point the animal is re-evaluating its response. We are plotting response by V max in this axis. So, the maximum is 1, right. So, when it is actually looking at what it should be responding to, then at this point, that is at V4, the beginning of the fourth trial or the end of the third trial. So, then you can see the change, then here we have to write it for tone, also for the background. So, for the tone it is going to be, it will be alpha tone times V max minus summation of both, right, until now we whatever has been acquired, which is V tone component is just only one time, which is alpha tone times V max plus all the background components, right. So, it will be alpha BGD times 1 minus alpha BGD and so on and so forth. Sorry. At this point in time, the response, actually we should go back and see what the response is. So, the response here would be the V1 BGD, we found it to be alpha BGD to Vmax plus here we have alpha BGD times 1 minus alpha BGD times Vmax, and if there is a third instance, one can actually go ahead and write down and so forth, all right. So, and go ahead and write down, and there is a general expression. I think it is a good exercise to look at it. There is a general expression one can obtain for repeated presentations of these things, but however, let us not lose track, and for every shock alone presentation, right, so called the shock alone presentation, there is an increase, or there is an increase in response for the background, and that is given by this. So, at the end of the second trial, just this alone would be the response, and if there is repeated presentations in general for nth one, we can write like that. And keeping that in mind, now let us come back. We have to add in all of this. So, the response would be response at that position, right. So, that would be alpha BGD Vmax plus alpha BGD times 1 minus alpha BGD times Vmax and so on and so forth, many terms together. And then, so what you can actually see is that if every single time a tone and the shock were to be presented together, or the shock were not to be presented whenever there is no tone, then no way the value of the background would have gone up. But because it is being presented all throughout, what is happening is that whenever the shock is presented without the tone, the background conditioning happens at the cost of Vmax, at the cost of V tone. We will see in the next lecture. Thank you.